So today we will be seeing first thing how to set up local Spark in a Scala ID, right? So the first thing what we need is a Scala ID. So it's very simple. Go to Google, search for a Scala ID, and install it, right? Simple. So go here, go for Scala ID for Eclipse, download it. It will be downloaded and open it. The second thing what we need is Spark download for Windows. So go here and download the Spark library, this one, right? The third thing what we need is Windows util extensive, Windows util.exe. Go here into the first link, and at the end you will find the Windows util.exe, right? And the third thing and the fourth thing is Java JDK 1.8 or any version of JDK, right? Just to see the compatibility. Go here and install the JDK for your Windows option. Now you need to edit some environment variables. So what you need to do, first of all the Spark, JDK, and Windows util. So what you need to do with Windows util, you need to go to your let me see quickly, environment variables. So you need to go to environment variables. So I'm just seeing the path. So you need to create 3 variables, right? In the first variable is Hadoop underscore home, and inside this variable you need to put the directory where you will be copying your Windows util.exe, right? So inside Hadoop you need to create one folder in a small case bin, and inside bin you need to put Windows util.exe. Now the question is, what is winutils.exe? It will create a Hadoop virtual environment for you guys. Okay. The second thing, in your environment you need to create Java home. This is the path for your JDK 1.8 where you have installed, right? The third thing is your Spark home. Spark home is the home. So when you download the Spark, it will be your zip file. So you can install or you can unzip that file in any folder, right? I have unzipped that file into my home directory inside a Spark folder, and I copied the path of that Spark folder here. So these are the setup what you need to do. Then you need to go to your Eclipse, right? You need to go to your Eclipse where you like the Eclipse is in my downloads. This is the Scala ID. I need to go here. I need to go to Eclipse folder, and I need to click this eclipse.exe, and it will open Eclipse exe for you, right? Now the second thing what you need to do, you need to create a Scala project here, right? Let's say my and Scala Spark project, right? Sorry, project. It will create a Scala project for you. Now here you need to go, you need to create a new Scala object, right? Let's say Spark program, anything you can name, doesn't matter. Inside this Spark program, now into this object you need to import something. I have copied it here. Yeah, so first of all I'll explain to you what I'm importing. So but you need to import this thing, right? What these imports are? These imports are Spark session, Spark conf, Spark context, and this is duplicate, so I'll remove it, and some logging information. But the question now here is, this is not getting recognized, right? Why it's not getting recognized? Because this Scala IDE, Eclipse Scala IDE, has no linkage with our Spark, like where we have installed Spark. So what we need to do, we need to go here and add all the libraries what we have here. So go to external jars, and inside your Spark folder, I will tell you the full path. So into your Spark folder you will have jar folder, right? Spark home, then Spark 2.8 Hadoop, then jars. You need to select everything, say open, and the jars will be added here. go to apply, and go to apply and close. But now we can still see these errors are not gone. The answer to this question is why it's not gone. Our Scala version and our Spark version are not in sync. So what we'll do, we'll go to properties, we'll go to compiler. What we can see here, it is using latest 12.12 bundle, but we need to use, for this version, we need to use 2.11 bundle. So we'll go apply and close, go to apply and close, and okay, it is gone. So what it means, I'll repeat the steps again. Download Scala ID, even let me write it down so that we can have a note later. Where's my pen? Quickly. Yeah. First step, install Scala ID, that is Eclipse, right? Second thing, download and unzip Spark, right? Third thing, download winutils.exe and put it under Hadoop bin folder. Fourth, what is that? Download JDK 1.8. Fifth, add Spark home. Second, Java home. And third, Hadoop home. So the Spark home is the Spark folder location. Hadoop Java home is the JDK 1.8 folder location, and Hadoop home is this folder where you put the window utility.exe. And the final step is change the Scala version. And don't change it blindly, change it by using seeing the compatibility, right? For me, 2.11 is the Spark version. Okay, so this is good, right? So we are good till here. So what we have done, we have installed Scala ID, we have downloaded and unzipped the Spark, and then we have added few folders, right? And now my Scala ID is integrated with the Spark. Okay, so let's do one thing now. So we'll go here. I'll just copy this part for a time being, and I'll explain to you. So what I'm doing here, so for any Spark program, the entry point to the Spark cluster is a Spark context. Into your Spark shell, we have Spark context by default to us, right? Spark has created this Spark context to us, right? Spark has created this SC Spark context to us for default. But when we want to use Spark installed with the Spark which is installed onto our local, we need to create this Spark context so that our Eclipse ID can talk to the Spark which is installed onto my local. So what I'm doing now, first of all, I need to tell the configuration object where my two things, right? The first is my app name. The app name can be anything. So let's say I can change it to test app, right? And then I do tell where is my master, right? The master means, so I have already explained, right? On a very high level, I haven't touched the Spark architecture yet, but in Spark, we have master and then we have executors. So I need to tell where my master is and how many cores of this particular laptop on which I'm running this code, how many cores I need to use. So what I'm telling here, that okay, used all the core. Star means use all the cores. Then once this configuration object is created, I need to pass this configuration object into Spark context, and I need to create the SC now, right? So if let's say, if I say print SC, and I'll go here, I'll go to show view, others, and then console. One more thing, right? So this object which I have created has no main class. So either we can create a main class, right? See, this is object, right? And to execute it, it will need a main class. Main class for the object execution. This SC is for the entry point to the Spark cluster. But if we don't want to add the main class, we don't want to go into that multiple lines of code, we can say extends app, right? So what this line will be doing, this line will add the main class. So if you just hover over here, it will tell you the same thing, that the object main inherits the main method of the app, right? And now if I go here, if I say run as, you will see the Scala application. But if I remove this, okay, let's say if I remove this, and if I go here, you can't see the Scala application here, right? So let's Control Z, and I'll go here, run as, and you'll say Scala application, and why it's not running? The main class is Spark program, Spark program, and run. So it's running. So what I asked is to print the Spark context for me. So this is my Spark context, right? So it has created one Spark context. In the same way, Spark has created the Spark context for me. So see this thing, right? org Spark, Spark context, and some address to that variable. Same thing we have done here. So we have replicated that, right? Now the question is that how to see, for me, I am only interested in this line, right? I'm only interested in this line, and still lot of logs are coming, right? So what I need to do, I need to go for logger dot get logger, right? And in the class we can say org, and then dot what I can say, dot set level, and then I can say error, or I can say level dot error. So what I'm doing here, now I don't want all this stuff, right? I don't want all this stuff. So I'll just, when I run this program again, it will only show me the thing what I need, right? Let's see if it is working. Perfect. So all the extra logs have been gone now, and we are only seeing the required thing what I have printed, right? Okay, let's do one more thing. Let's create one test file here. Just for my sake, let's say we want to create a new file just for the testing, right? Any text file. So I'll say here, this file name is order.txt, orders.txt. And what I'm doing here now in this file, what I want, so I'll just copy some order details from order.txt file, which is into my onto my SDFS. Okay, I need to copy it here. Some files, like we have 68,000 orders, but I don't want to copy all. I just need to copy something for my testing. Okay, so I'll just show here. I'll say copy, and I'll paste this sample orders in here. Okay, and I'll say save. Right now, let's say if I want to read this file, right? So what I need to say, here val orders equal to sc dot text file in double quotes. Since this file is present into this particular context, so I do not need to give the full path. I'll say orders dot txt, right? And if I say print orders now, so it will print this RDD and it will show me the type of the RDD now. Okay, let me show you now. Or I can say here orders dot, let it come. So it will show me the type of the RDD, right? Or you can clearly see here that this is the RDD of string, right? This is the RDD of string. Now let it run. So yeah, it has created for the orders.txt map partition RDD. It has created an RDD for me. Now what we need to do with orders file, let's call this as orders file, right? And let's comment it for a minute and we will say, well, now what we can see into this file, right? We have order number, order date, something else, I'm not sure what this field is, and order status, right? So we have 4 fields. These 4 fields are comma separated, right? These 4 fields are comma separated, right? So let's do one thing. Let's create orders map is equal to, now we need to process the orders file, right? So we'll say orders file, and we need to call the map function. Why we are calling the map function? So that we can split the rows, right? So we'll say x means x represents each row in that file. What we need to do in that each row, we need to say x dot split. On what basis we need to split? We need to split on comma, right? So what this order map is? Order map is RDD of array of string. This is RDD of string, right? So now the question is, what people can ask you, the split function will always give you array of strings, right? The split function will always give you array of string, right? So now let's control Z here. So now we have orders of map. Now let's say from this file, I want to count number of closed orders, number of pending orders, like types of order. I want to count of them, right? So what I can say, now let's do one thing. Well, order type. Now I'm extracting order type from order map, right? So I need to say order map dot, again I can map, right? And now from this orders map, which is an array, this order map is an array. How we need to extract the 4th record? Simple, right? So from each element, which record we want? We want the 4th record. Since arrays are 0 index based, so it's a 3rd record, right? As simple as that. And let's say till now we are good here, right? And let's say we want to orders type, and let's say we want to create a pair RDD, right? So this is sorry, oh, because of this, one second. So this is your orders map, sorry. So this is the orders map, right? So now this is your RDD of string again. So it means this RDD is containing each string, right? And let's say if I want to create a pair RDD, how I can do the pair RDD? Pair RDD means the tuple. How tuple looks like? Something like this. So let's say my order is complete and I need to put 1 here, right? So it will be a paired RDD. So how I need to create the paired RDD? So what this thing is doing, for each element in the array, it is picking up the 3rd element or the 4th element. I need to append, I need to create an tuple. So I just need to put a bracket, right? This is done. So means this bracket is producing. Now I need to put 1 here. right? And now when I see the output, it is RDD of string and int, right? It is an RDD of string and int. So it means tuple of string and int. String is order status and int is just one, right? Now let's say if I want to count the number of orders with each status, what I can do? I can copy this and I can simply say orders dot count by key. Simple. And I'll explain a lot of functions and a lot of transformations for you today, but this is the first function. And let's run it. Okay. So ideally, it should give me a map with key as the order status and number as the number of time that order status has been found there, right? Let's see. It's taking time. It's done, I think. So let's say we want to print it. Let's see. So it is compiling it. Okay, so it has created the map, it has printed it. So it means into this particular sample of records, right? How many times payment review status came? 3 times. Close type 59 times, and so like completed 171. So what it did, it created a map with the number of, like, with the key, map key as the order status and the map value as the number of time that order status appeared into the file, right? So this is done. Now let's say if we want to create by number of amount, like value, right? So what do you say? Value. See, one important thing which I need to cover here, since this record is a tuple or is a pair RDD, we can use by key by value function with ease, with lot of ease, right? And this is the beauty of paired RDD. Okay. After this, we'll jump to the theory, but let it come. It will give you something like one, like complete comma 1 and then the status. Let's see. So it will give us the whole value and it will give something like this, 55. Yeah, exactly this. So it will give us the full value and then the status, cancelled as updated 16 times and whatever, right? So this is good. Now let's jump here. So this is pretty clear to you guys that, okay, and this is the most easy way to learn Spark onto your Scala ID. It's easy to type, it's easy to learn, it's easy to compile, right? Now let's jump here on the RDD. So now all these functions are easily applicable to the key value pair or to the pair RDD. For the pair RDD, we need a tuple. We need a tuple of 2 elements, in which if we want to process them, the Spark will consider the first element as key, the second element as value. So let's say we want to go over reduce by key, right? Let's say we want to go for reduce by key. So let's go for reduce by key here. So how reduce by key work? Reduce by key, and the reduce by key, we need to give 2 elements. The first element, and let's say we want to plus it. Okay, and let's print it. So I will explain reduce by key, how reduce by key works in this way. Let me go here on the plan paper here. So let's remove this all. In fact, a second, guys. Oh yeah. So how reduce by key works? So let's say we have 2 tuples with complete comma 1. I have created this, right? And I have one more thing, complete comma 1. and I have one more thing, let's say cancelled, comma 1. When I run reduce by key here, how it will work? So it will only work on keys, right? It will only work on keys. So these are my keys and these are my values. So how reduce by key works? It will take two parameters, first, and then it will do some operation, and then second, right? And it will always do the operation on the value. So it will reduce by key and do the operation on value. So for here, the key is complete and the value is this, and I'm asking to add that key. So what it will do? It will reduce all the common keys. So what it's gonna be doing when I say, or it will be, it can written like this: reduce by key x comma y implies x plus y, and these x and y are consecutive rows values. So this value and this value. So what it is telling me that okay, 1 comma 1 implies to 1 plus 1. So it will give me 2. And let's say if I have one more complete here and comma 1, so these two have been reduced. The result came as complete comma 2. So the result of this is complete comma 2, and now it will take this one and it will go, since this complete and complete keys are same, it will go on 2 comma 1, and since my function is x plus y, so it will say 2 plus 1, and it is 3. So let's see how it works for me. So this is how reduce by key work, right? Okay. Oh, one more thing, right? So this is again a very good example, right? So when I apply an action, it prints the result, right? So we know one more thing. I'll remove this. 1 second. So we know one thing, right? So when we apply transformation to an RDD, it will give us an RDD, right? Making sense? And when we apply an action to an RDD, it will give us non-RDD. Non-RDD means maybe a map, maybe a string, maybe an int, or something else. Something which is not RDD, right? Now let's go here. So first, I applied two functions, count by key and count by value. So these were actions. So you remember both function gave us map. Map of what? Map of values and like the status of orders and count. Status and count, right? Now what I applied a transformation, reduce by key. So what it gave us a new RDD. It gave us a new RDD, right? So ideally, what I need to do, I need to go here, and let's say if I want to do some action onto this RDD, I'll say for each, how for each work? For each element of this particular RDD, do some function. F means function. And what I need to do, I'll say print ln. So print ln is a function, right? Which will print the each line. And now let's run it again. Okay. So this is how it's working. Let's run. Perfect. It worked, and it worked like a charm. So count by key, count by value, reduce by key, all gives us the same result, right? Now let's do one more thing. Okay, let's do one more thing. So we need to go for sort by key, right? So right now, how result came? Result came in any order, like P, C, pending, cancelled, pending, on hold, suspected, complete. Let's say we want to result them in sorted way with alphabetical, right? So what we'll see? Before this, what will say? Dot sort by key, and in this function, let's say on which, so one thing we know, right? This is a tuple, or in the how we need to explore, or how we need to get the first element of tuple like this, right? Sort by key, and it's not, one second. So here it is by key is done. So we have key here, and let's say sort sort by key is here, ascending by default, and let me see, and then for each, and then print ln. Okay, so it sorted for us, right? Ideally, sort by key has two functionalities, if I'm not wrong. One second. So it worked for us, and it has sorted our result. What I was thinking when I go here, sort. Okay, so two things. I was confused between sort by key and sort by, right? So let's go for sort by. So inside sort by, so see, sort by key will only work with your paired RDD, but if you have non-pair RDD, you can do like this: x dot, since I have a tuple and I need to go for first element, I'll say _1, and then just remove this, and then for each, right, and then say println. Okay, and let's run it. It will give the exact result to us. Okay, so sort by key. Now while it is running, let me explain here. So sort by key and sort by will give same result. Both are meant for sort by. The difference is it is for pair RDD, and it is all the parameters for this function sort by key are optional. By default, it will take the key and it will sort that key in the ascending order. This sort by function will take one mandatory parameter, and that's some anonymous function in which you need to tell the function on which key you need to sort the result, right? And this is what I did here. So it did exactly same thing for us. Sort by key. Okay, one second. So it is 0 based. So I need to go for 0. So it is 0 based, right? So it is sorted on the value 159, 122. It got confused actually. Sort by key _1. Ideally, it should work. And when I go for 0, it is 2 string int 1 string int. So I need to go for 1. It should sort. I'm not sure why it's sorting, but yeah, this is how it works. Okay. So if you have your key RDD, then you do not need to worry about all this stuff. You need to just go for key and you need to put this and it will work for you. And that's the function, that's where the pair RDD will make your work so easy. If you have two elements into your RDD, you will apply this key function very easily, right? So this is good. And now let's go for few other functions. So map function we have used here, right? Now let's say we want to go for filter function, right? Let's say we want to go for filter function. How filter function works? It's easy. So we'll go here. And let's say we want to create a new RDD. Well, orders filter, right? Equal to, and from this orders file, we only want to filter all the rows which have closed keyword, right? Which have closed keyword. So what will say? Orders file dot filter, right? Filter function will accept a function. So we can either give an anonymous function or we can create our own function. Let's give an anonymous function here. So we'll say x, and what x needs to do? If x equal to closed, if x equal to closed, then give me only those results. Right? And now let's say if we want to count only this file and we want to print it, let's see, it will only give us closed results. It will only give us the output only for the closed result, let's say, right? This is how filter function works. Flat map, I already told you, flat map and map are exactly same. Flat map will give you a different row for each word. For example, if you have words like this, hello, how are you, and you apply flat map over it, so it will give something like hello, how are you. If you apply a split with flat map, right, so it will give you separate lines for each word, right? Map will give you one-to-one result. For example, what we have done here, we have applied map here. Where did we apply map? Yeah, here, right? We apply map here, and for each row it appended one and it created a tuple of each row. So when we want to function on each row, we can go for this, right? 1 second. Orders dot CLOSED. 1 second. Let's see why it's not working. X dot closed. We have closed here, and orders map, orders type. And then we put one here, and so let's do one thing first. So let's comment it, and let's comment this as well, and let's do one thing. So we'll say orders, Control Z, orders filter dot for each. I'll just want to see the result, so I'll say print ln. Okay, let's see what is coming into my orders filter. It is not showing us anything. Reassign to where it is comparison orders file. Okay, sorry, maybe. Okay, let's do one thing. X dot contains, and I want to go for this, let's say, right? And I'll go here. The equal to signs are not okay. I know what's not working. Like, I'll explain it to you. If it works, I'll explain it to you. Okay, it worked, right? And why it was not working before, and let's comment this line, right? And let's uncomment this line, orders type, and let's uncomment this line, right? And let's run it again, and then I'll explain you why it's not working. So when, let me explain it to you here. So when I was using orders dot filter, x implies x equal to closed, right? And it haven't give us any result. Why it didn't give us any result? Because when we see any copy, let's copy this row. This is one of the row, right? So when I copy it here, so is this row equal to closed? Equal to closed? No. Yeah, but this row contains closed. This row is not equal to closed, but this row have one word closed. So what I did, I removed this portion and I copied it x dot contains and the same thing closed. So it worked for us. So equal to will work if we have only closed into this. It will work like a charm, right? It will work like a charm. But if we don't have anything, it won't work. Okay, so let's go here, and it worked. So closed appear 59 times. But let me explain that thing to you as well. So let's remove this thing, okay? And save it. And let's go here. Let's put equal to here now. Equal to, and remove one bracket. And let's comment this all. Okay, and let's do it. It will give us only one row now, because one row has exactly closed into it. Okay, let's see if it works. No, it not work because it has some. Okay, 1 second. I know, because we haven't splitted it. So we need to split it, and it consider the whole file as one row, and we haven't splitted it. So if we splitted it, then it should have worked. Okay, so I won't go there, but this will work if we have exactly one row for closed. Okay, so this is how filter by works. So filter by work for us with contains. Okay, so when I go here, I can show you, let's say it contains, and it will work. So it worked like this. That's good. So this is how your filter clause work. So I have covered filter map. Okay, so map partition and map partition with index. This is very interesting, right? And I have created a small description for you guys here, right? So, okay, so when we talk about map, how map works. So let's say here, I'll go here and I'll see this example, right? So let's say you have this RDD. You have this RDD, and let me do it for you. So I'll just go here and I'll copy this portion. Okay, and I'll go here and I'll paste this portion here. Okay, so let's say you have this RDD which has 3 partitions. Okay, you have this RDD and you have 3 partitions into it. When you apply map function to it, how map function works? So it will instantiate each function on each row. How many times it's going to be? Let's say 1, 2, 3, 4, 5, 6. So we have 18 rows here, right? 18 rows distributed across 3 partitions, right? So how map function will work? When we call map function, it will invoked 18 times. So obviously, when we talk about function invocation, it is expensive activity. When we invoke a function, it needs to create some environment for it, it need to remove the environment, garbage collection, and number of things. So what these people think about, why can't we work on partition level? Why can't we work on partition level? Then this function created two functions for us. So this is how map works, right? If we talk about map partition, map by partition, this one, map partition, how it will work for 18 rows and 3 partition, it will be invoked 3 times. It will be invoked 3 times. So for each partition, one map function will be invoked. Here also 1, and here also 1. So the map partition will invoke as the number of partitions are there in the RDD. Similarly, map partition by indexed, map partitions with index work. So ideally, each partition has an index number associated to it. For example, if you have 3 partitions, the partition number starts with 0, 1, and 2. Right? Let's say we want to use this index number into our processing. Let's say we want to use this index number into our processing. In fact, let me show it to you. I should have notes somewhere. Yeah, so let's do it quickly, okay? Yeah, so let's say I want to create, and I'll go here, not there. I'll go to my Spark shell, and I created one RDD using Parallelize, right? RDD can be created in multiple ways. Once you read a file using sc.text file or any other file reading operator, a RDD is created. But let's say if you want to create a RDD for your testing purposes or for anything, you can use Parallelize clause, right? So I'm creating a RDD using range operator, 2 operator from 1, 9 to 3, right? And I want to, okay. So how Parallelize clause work? So Parallelize clause work like this, okay? Let me explain here, and then I'll go ahead. So RDDs can be created in 2 ways. The first, you can read a file using sc, Spark context. Second, you can use Parallelize, right? Parallelize take 2 parameters. The first is the data structure which you need to parallelize, and the second, in how many partitions you want to split that data structure. So this is a data structure, and this is the number of partitions, that's a 3. So what I'm doing here, I am creating a data structure which has 9 values into it, and I'm splitting those 9 values into 3 partitions. Then what I'm doing, for each of the value, I'm creating a paired RDD, and I'm appending hello to it. How it will work? It will work like this. So I have 1, 2, 3 in first partition, 4, 5, 6 into second partition, and 7, 8, 9 into 1 partition. So this is what Parallelize clause did for us. Now I have called a map function on each thing, and I have appended hello to it. So it will work like this: hello, comma hello, and for each hello, hello, right? This is how map function will work, right? When I call a map function, it will call 9 times, and it will append hello to it, right? So let's see here. So this, I call a map function here, and I'll say collect, right? So what it did for me, it appended hello to each operator of my array or my range, right? Now let's do one thing. Where it is here. So now let's do one thing. Now let's see the partition size, right? So obviously we know that we have splitted the number of these elements into 3 partitions, but let's say we want to check the partition size, right? So the function, or how to see the partition size, so what we can say, RDD dot partition dot size. So let's say we go here, we paste it here, and we say it will give 3 to us, right? So it means it is distributed across 3 partitions. And when we see here, it is called 9 times, right? We know. Now let's go for map partition. So for the same thing, if we want to go for map partition, we'll do like this. So we'll paste it here, and when we run it, it only worked 3 times. Same thing, right? I'll explain it to you in details now. So what we did, we have created number 1 to 9, divided them into 3 partitions, right? And then we call map partitions over it. Inside map partitions, we say that, okay, over each partition, right, iterate an array over each partition. So what, see, map partition will take a iterator. Iterator means, so see how map partition will work, right? So map partition will work something like this. So how map partition will work? Map partition want to work on one partition at a time. And since we are talking about one partition can have multiple elements into it. So obviously what map partition will take? Map partition will take a iterator, right? It will take a iterator. Iterator means one function which will iterate through all the elements of map, right? Here what we did, we, into our example, we created an array of hello and we call dot iterator over it, right? So that it will act as an iterator and it will give us a result for each partition. And since we have 3 partitions, it gave us array of 3 hello. Why? Because we have 3 partitions and we have called array on each partition. This is how map partition will work. Now let's see how map partition index will work, right? So map partition index will work something like this. Map partition with index. So let's say we do the same thing. We create one more range and we split it across 4 partitions, and number 1 to 25 will go to partition 1, 25 to 50 go to second partition, and so like this, right? And then what we did, we created a base. What we are calling on base RDD, map partition by index. So map partition by index will take 2 parameters. One is index. This index is nothing but the partition number, and iterator is same what we have iterator here. Iterator means a data structure over which we can iterate, right? So when we hit enter, it will ask us what we need to do inside this function. So what I need to do on each iterator, I need to call a map function. Inside this, I want to call a map function iterator. So over this iterator, I need to call a map function, and I need to assign x, right, over each element. So it will be 1, 2, 3, 4 till 25 for the first partition. I will say, give me index of partition and the element. Index of partition and the element, right? And then I'll say, print this result for me. So print this result for me. So what it will do? It gave us all the elements, and it started with partition has started from 0. So for 0th partition, it gave me 25th row, right? 25 row till here. So what it did for me, how map partition by index with index worked. So it took the index means the partition number, and it took the element and it returned the partition number with element to us. This is how map partition with index work. Okay, let's go over the theory a bit more. So map partition and map partition with index, these 2 methods are able to address the situation. So for example, let's say we want to process each element on a partition. So map will call the number of elements are there. So let's say if there are 18 elements, map function will be called 18 times. But map partition and map partition with index work on the partition, not on the elements, right? And these elements will create the parser instance for each partition. So these methods like map partition and map partition with index will create one parser for each partition. So if we have 4 partition, the 4 times it will be created, so it will be more efficient because we do not need to garbage collection, we do not need to create the instance, a lot of things can be saved. This is the benefit of map partition and map partition with index. So it's preferable if you want to use map partition, use it in case of instead of map, right? So this is how these few functions work. So I have covered all these: map, filter, flat map, map partition, index. Let's see few more functions today. This union intersection. This is very, very simple things. Let's see here. So let's do one thing. So for union or intersection, let's create one more RDD. So let's call that RDD1. One second, why it's not working? So we'll say simple SC, and we'll say enter. We'll say enter. It worked. So we have one RDD here. Let's create one more RDD, right? And inside this RDD, one second, I did something wrong. So instead of this, it should go here. So I'm just creating RDD for the dates, okay? And I will go for sc.parallelize here for a time being, and it should work. Yes, it should work. So now it is working. I'll create one more RDD, RDD2. Inside this RDD2, I want to go for only 2 elements, let's say. And let's say we want to go for, here I just changed one date, 2015, right? So we have 2 RDDs, RDD1 with 3 dates, RDD2 has 2 dates. Now let's see how RDD1 and RDD2 will work with union and intersection, right? So let's say RDD1 dot intersection in function. Since it's a function, we'll call RDD2. Ideally, what should it should give? It should give one result, that is one. So it will give us a new RDD, and let's say for each, then we'll say println. So it will give the common date. So we have 2 RDD. We had 2 RDD. The first RDD has 3 dates. 1st Jan 2016. The second RDD is 3rd November 2014 and 16th Feb 2014. In the second RDD, we have only 2 dates: 1st Jan 2016 and 16th Feb 2015. Right? So 1st Jan 2016 is common across both the RDDs. So when we do the intersection, it gave us 1st Jan 2016, right? And when we do union, it will give us everything, right? So it gave us everything. One more thing on the union, right? So when we talk about union in SQL, union will only give us distinct result, but when we see here, it gave us non-distinct results. So it gave us everything, but it combined the 2 RDDs, right? When we go for, what are the other operators? So the other operators were union, intersection. Let's go for Cartesian, right? Cartesian will do the Cartesian product. Cartesian dot Cartesian. So it will just multiply it. So we had 3 and 2. So it will say 3 into 2, 6 elements. So it gave us 6 elements, right? So it just multiplied the first RDD with second RDD and gave us the result. Now let's say we want to go for this result, union result, and we want to call, obviously for each will be here. One second. Yeah, and we want to see, so when we see here for the union result, we see two different distinct element. First gen 2016 came twice. Let's say we want only the distinct element. Distinct dot this. So we only have distinct element. So first gen 2016 came only once here, right? So distinct will remove all the duplicates. Minus will remove. Let's go for subtract. Subtract. So what subtract will do? Subtract will remove all the common elements from the first element. Let's say sub will show the result. It will be easy to understand. So what it will do, in the first RDD, I have 3 dates, right? And the first gen 2016 is common across both the RDDs. So when I subtracted the RDD2 from RDD1, it just removed the common elements, right, from the RDD1. This is how subtract is working. Cartesian, coalesce and repartition I'll cover in let me cover it, okay? So what coalesce will do, coalesce and repartition are transformation which will increase and decrease the number of partition, right? So let's go for here. So when I go here, not here, this one. So let's say if I have a base RDD, right? I have created one base RDD in which we have 4 partition, right? So when I go here and I want to say base dot partition dot size, how many partition, right? What's the function? So it was partition dot size, right? Partitions dot size. So when I go for base dot partitions dot size, so it will give me 4, right? It gave me 4. So it means I had 4. I have divided this RDD into 4 partitions. Let's say if I want to reduce the number of partitions, what I'll say, base dot coalesce, ESCE, and then 3. Now what, okay, let me do one more thing. I'll say new base equal to this, and I need to put val here. Okay, and when I say this function on new base, not this one, new base, so it will say me 3. So what I did now, I created a new RDD. And I call the coalesce function into it, and I reduce the number of partitions into it, right? So coalesce will be generally used when we want to reduce the number of partitions, right? And when we go for repartitions, right? When we want to go for repartition, we will be using, let's say I want to create a 6 partitions now. So I will be using repartition here. So let's say repartition. And when I go for new base now, so it will give me 6. Now the question arises, can I use coalesce to increase the number of partition? Yes, we can, right? But very interesting thing, right? So coalesce, although I increased the number of partition to 6, coalesce increased it only to 4. Let me increase to 12, and still coalesce will increase to 4, right? Because I think only what coalesce will be doing, very interesting thing. So what are the number of partitions into my base RDD? So when let me say here, so my base RDD has 4 partitions, right? And what I did, I called coalesce to increase the number of partitions to 12, but it won't increase, right? It just does the number of partition to 12, right? So coalesce won't be increase the number of partition more than your base RDD. But when we call repartition to increase the number of partitions to 12. And when we call C this new base partition, it will increase to any number of limits, right? Now the question arises, can we decrease number of partition using repartition? Obviously we can. So when we go here and when we put 3 here and when we see the size, it is 3. Now last question on this, then why coalesce comes in picture if repartition can do both things? Repartition can increase the number of partitions and can decrease the number of partitions. Then why these guys created 2 functions for us, right? So what the internals behind the scene is, in coalesce, how it is doing. So what is going on behind the scene? Let's say here somewhere I copied it, right? Yeah. So let's say you have 3 partitions, right? And you want to make 2 partitions. These 2 partitions are on same data node, right? And this partition is on different data node. And if I asked machine to create 2 partitions out of 3, so what my Spark will do if I call coalesce, it will merge all the partition which are on the same data node into one. So this will be 1 partition and this will be 1 partition. But if I call repartition to decrease the number of partition, it doesn't care. It can merge some elements like these 3 elements. In fact, let me delete it so it will make more simple for you to understand. When we call repartition to decrease the number of elements, decrease the number of partition, and we assume that these 2 partition are on the same data node or same executor, and this is on data node 2. Spark don't care if you call repartition, it may merge these 4 elements with this and these 2 elements with this. So there will be shuffling for sure, and repartition is always an expensive operation since it will call shuffling. But when we call coalesce, if there are 2 partitions sitting on the same executor or same data node, it will try to merge them, and that's where it won't go for shuffling, right? And this is where we have covered almost each operation. So now coming for action. So when we call action, obviously the DAG which is created behind the scene by the transformation will be executed. So actions are pretty easy to use, nothing very fancy. So when we want to go for the first element of the RDD, we can go for first here. This is the first, right? When we want to take, let's say we have one second. So we have, let's say 100 elements, right? And we want to take 4 elements out of it. So this is base dot take 4. So what it will say? It will only give the 4 elements. And let's say we want to take the first element, right? So we'll say first, and it will only give the first element, only 1. This is how the actions are pretty simple and very, very easy to understand. Now, let's say if I want to count it, right? So what I can simply say? I can simply say count. So it will count the number of elements. Since the elements are 100, it should give me 100, right? If I want to go for max, I can say max. Same way the minimum will work. Minimum will give me 1, right? So this is pretty simple, easy to understand. Mean, variance, standard deviation, it will work easily. For each, we are using multiple times. Collectors map is very, very interesting thing. So if you have a tuple in which you have 2 elements, if you want to collect that tuple RDD, tupled or pair RDDS map, you can use collectors map. And these are some of the functions in which if you want to save the result as a text file, so let's do it, right? Save as text file. So let's say if I want to save this base RDD as text file, save as text file, and then the path. So let's say if I want to save this file into temp folder, inside temp folder, let's say. So save as text file is not a member of RDD. 1 second. save as text file. Oh, sorry. So everything will be in camel case. So this T should be capital. So now what it is doing. Okay. So what it says, temp directory already exists, right? Obviously temp is already exists. So what I'll say, temp underscore directory from Spark and this. Okay, so it will be done. And now if I go here and I'll say Hadoop fs-ls temp tmp directory from Spark. So it should give me my result. Yeah. So yeah, one more important thing now, right? And this is interesting. So what is the partition size for our base RDD? The partition size for our base RDD was 4, right? Was 4. When I save this file, so number of output files in MapReduce is equal to the number of reducer. Number of files in Spark will be number of partitions. And when I save this file, since I have 4 partitions, I have 4 files here. When I go for first file, let's say if I want to see the first file, part 00000, and I'll say cat, it should contain 1 to 25, right? Yeah, it contains 1 to 25. And this is how these different operations, save as text file, Parquet file, sequence file will work. Okay, so today we have covered almost every action and transformation which exists into Spark. Okay, so this is very important lecture. Do go through it multiple times if you want, but this is very important. When we talk about pair RDD, we can use by key operations. We can use by keys operations, right? When we go for any other RDD other than pair RDD, so obviously these operations what we have used here can be used on pair RDD as well, but pair RDD has some special functions, which is by key operations. So these functions are applicable to each and every RDD, but when we have keys and values in the RDD, then by key operations are easy to run. Okay. I think that's all for today.